There is no National Electrical Code, or NEC, code that requires insulated grounds on all receptacles in an office environment. The National Electrical Code provides comprehensive standards for electrical installations to ensure safety and proper functioning. Grounding is a critical aspect of electrical safety, designed to protect individuals from electrical shock and prevent equipment damage. A grounding system provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to operate and clear the fault. There are different types of grounding systems, including equipment grounding and system grounding. Equipment grounding connects non-current carrying metal parts of electrical equipment to ground, such as enclosures, conduits, and raceways. This ensures that if a fault occurs and a metal part becomes energized, the fault current will flow to ground, tripping the overcurrent protective device. System grounding, on the other hand, connects the neutral point of the electrical supply system to ground. This helps to stabilize the voltage and provides a reference point for the electrical system. Insulated ground receptacles, also known as isolated ground receptacles, are a specific type of receptacle designed to reduce electrical noise and interference in sensitive electronic equipment. They feature a grounding terminal that is isolated from the receptacle's metal mounting strap and the building's grounding system. The isolated ground terminal is connected to a dedicated grounding conductor that runs directly back to the electrical panel's grounding bus. This dedicated grounding conductor minimizes the flow of common mode noise currents, which can interfere with the operation of sensitive electronic equipment. While insulated ground receptacles can be beneficial in specific applications such as computer rooms, medical facilities, and audio recording studios, the National Electrical Code does not require them for all receptacles in an office environment. The decision to use insulated ground receptacles depends on the specific needs of the equipment being used and the level of electrical noise present in the environment. The National Electrical Code outlines the requirements for grounding in Article 250. This article covers various aspects of grounding, including the types of grounding systems permitted, the size and installation of grounding conductors, and the bonding of metal parts. Section 250.146 addresses the use of isolated ground receptacles, outlining the conditions under which they are permitted and the requirements for their installation. It is important to note that isolated ground receptacles should only be installed when necessary, as they can create potential safety hazards if not installed correctly. The dedicated grounding conductor must be properly sized and connected to the electrical panel's grounding bus to ensure effective grounding. It's also crucial to verify that the isolated ground receptacle is compatible with the equipment being used and that the grounding system is properly tested after installation. In summary, while insulated ground receptacles can be useful in certain situations to reduce electrical noise, the National Electrical Code does not mandate their use for all receptacles in an office setting. The NEC Article 250 provides detailed requirements for grounding systems, and compliance with these requirements is essential for ensuring electrical safety. It is always recommended to consult with a qualified electrical engineer or contractor to determine the appropriate grounding solutions for a specific application and to ensure compliance with all applicable codes and standards. Always refer to the latest edition of the National Electrical Code and local amendments for the most up-to-date requirements. Furthermore, proper wiring and grounding methods should always be followed according to the NEC. Grounding is intended to provide a path of low impedance for fault current to return to the source, such as a transformer or generator, and it is designed to trip a circuit breaker or fuse, which will de-energize the circuit, preventing harm to personnel and damage to equipment. When dealing with sensitive electronic equipment, it is important to ensure that the equipment is properly grounded and that any potential sources of electrical noise are minimized. This may involve the use of insulated ground receptacles, but it could also involve other techniques, such as filtering and shielding. Filtering involves the use of electronic components to block or reduce the level of electrical noise on a circuit. Shielding involves the use of metal enclosures or barriers to block electromagnetic interference. By implementing these techniques, it is possible to create a clean and reliable electrical environment for sensitive electronic equipment. The NEC provides specific guidelines for the installation of electrical equipment in different types of occupancies, including office buildings. These guidelines cover a wide range of topics such as wiring methods, overcurrent protection, and grounding. It is important to be familiar with these guidelines to ensure that electrical installations are safe and compliant with the NEC. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is developed by the National Fire Protection Association, or NFPA, and it is widely adopted by states and local jurisdictions in the United States. In addition to the NEC, there may be other applicable codes and standards that need to be followed, such as local building codes and industry-specific standards. It is important to consult with the appropriate authorities to determine which codes and standards apply to a specific project. When working on electrical projects, it is always important to prioritize safety. Electrical work can be dangerous, and it is essential to take the necessary precautions to protect yourself and others. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following safe work practices. It is also important to de-energize circuits before working on them and to verify that they are de-energized using a reliable testing method. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. Electricians have the training and experience necessary to perform electrical work safely and correctly. They can also help you to ensure that your electrical installations are compliant with all applicable codes and standards. The NEC contains a wealth of information on electrical safety and best practices. By familiarizing yourself with the NEC, you can gain a better understanding of electrical systems and how to work on them safely. The NEC is a valuable resource for anyone who works with electricity, from electricians and engineers to homeowners and dyers. Remember that electrical codes and standards are in place to protect people and property. By following these codes and standards, you can help to ensure that electrical installations are safe and reliable. If you have any questions or concerns about electrical safety, it is always best to consult with a qualified professional. The NEC, specifically Article 250, provides comprehensive requirements for grounding and bonding to ensure a safe electrical system. It is essential to understand that grounding and bonding are not the same thing, although they are closely related. Grounding refers to connecting the electrical system to the earth, typically through a grounding electrode system. This provides a reference point for the electrical system and helps to stabilize the voltage. Bonding, on the other hand, refers to connecting all metal parts of the electrical system together to create a continuous electrical path. This helps to minimize voltage differences between metal parts and reduce the risk of electrical shock. The NEC requires that all metal parts of the electrical system be bonded together, including equipment enclosures, conduits, raceways, and metal piping systems. This bonding is typically accomplished using bonding jumpers, which are short lengths of wire or metal straps that connect the metal parts together. The size of the bonding jumpers is determined by the size of the circuit conductors, as specified in the NEC. In addition to bonding the metal parts of the electrical system, the NEC also requires that the grounding electrode system be properly installed and maintained. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The grounding electrodes must be buried in the earth to provide a connection to ground. The size and type of grounding electrodes are determined by the size of the electrical system, as specified in the NEC. The NEC also contains requirements for the installation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electrical shock by detecting ground faults and quickly interrupting the circuit. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electrical shock. The NEC also addresses the use of surge protective devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. SPD are typically installed at the service entrance of a building to protect the entire electrical system. The NEC provides specific requirements for the installation and wiring of SPD. It is important to note that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. The NEC is updated every 3 years, and it is important to use the latest edition of the NEC when designing and installing electrical systems. In addition to the NEC, there may be other applicable codes and standards that need to be followed, such as local building codes and industry-specific standards. It is important to consult with the appropriate authorities to determine which codes and standards apply to a specific project. When working on electrical projects, it is always important to prioritize safety. Electrical work can be dangerous, and it is essential to take the necessary precautions to protect yourself and others. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and following safe work practices. It is also important to de-energize circuits before working on them and to verify that they are de-energized using a reliable testing method. If you are not comfortable performing electrical work, it is best to hire a qualified electrician. Electricians have the training and experience necessary to perform electrical work safely and correctly. They can also help you to ensure that your electrical installations are compliant with all applicable codes and standards. The NEC is a comprehensive document that covers a wide range of electrical topics. By familiarizing yourself with the NEC, you can gain a better understanding of electrical systems and how to work on them safely. The NEC is a valuable resource for anyone who works with electricity, from electricians and engineers to homeowners and dyers. Always remember that electrical codes and standards are in place to protect people and property. By following these codes and standards, you can help to ensure that electrical installations are safe and reliable. If you have any questions or concerns about electrical safety, it is always best to consult with a qualified professional. Furthermore, the integrity of the grounding system is paramount. Any compromised connections, damaged conductors, or improper installations can significantly reduce the effectiveness of the grounding system and increase the risk of electrical shock or equipment damage. Regular inspections and maintenance of the grounding system are essential to ensure its continued reliability. These inspections should include visual checks of grounding conductors, connections, and electrodes, as well as electrical testing to verify the continuity and impedance of the grounding path. Any deficiencies identified during these inspections should be promptly corrected to maintain the integrity of the grounding system. The NEC also provides guidance on the proper sizing and installation of grounding conductors. The size of the grounding conductor is determined by the size of the circuit conductors and the type of equipment being grounded. The grounding conductor must be large enough to safely carry the maximum fault current that could occur in the circuit. The NEC also specifies the types of materials that can be used for grounding conductors and the methods for connecting them to equipment and grounding electrodes. Proper installation of grounding conductors is critical to ensure a reliable grounding system. Grounding conductors should be installed in a manner that protects them from physical damage and corrosion. They should also be securely connected to equipment and grounding electrodes using appropriate connectors and techniques. Loose or corroded connections can significantly increase the impedance of the grounding path and reduce its effectiveness. The NEC also addresses the issue of stray currents in grounding systems. Stray currents are unwanted electrical currents that flow through grounding conductors and other conductive paths. These currents can cause a variety of problems, including equipment malfunction, corrosion, and electrical interference. The NEC provides guidance on how to identify and mitigate stray currents in grounding systems. Common methods for mitigating stray currents include isolating grounding systems, using dedicated grounding conductors, and implementing equipotential bonding. Equipotential bonding involves connecting all metal parts of a structure together to create a common electrical potential. This helps to minimize voltage differences between metal parts and reduce the risk of stray currents. In addition to the technical requirements for grounding and bonding, the NEC also emphasizes the importance of proper documentation and labeling. Grounding systems should be properly documented, including the location of grounding electrodes, the size and type of grounding conductors, and the methods of connection. Grounding equipment should also be clearly labeled to indicate its function and purpose. Proper documentation and labeling can help to ensure that grounding systems are properly maintained and that electrical workers are aware of the grounding requirements. The NEC is a constantly evolving document, and it is important to stay up to date on the latest requirements. The NEC is updated every 3 years, and each new edition incorporates changes and revisions to address new technologies, safety concerns, and industry best practices. Electrical professionals should regularly review the NEC and attend training courses to stay informed about the latest requirements.